Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Have you ever felt like maybe science gets things wrong, or that some scientific ideas just don't sit right with your beliefs? Well, today we're diving into a fascinating study that explores why some students, even psychology students who should know better, fall for what we call neuromyths, those catchy but completely false ideas about how our brains work. See, the internet is overflowing with information and not all of it is true, especially when it comes to our amazing brains. These myths, these neuromyths, are ideas about the brain that just aren't backed up by science, but they spread like wildfire. And they're a big problem, especially for psychology students, because they learn about behavior and the mind, and these myths can really mess up how they understand things. This study wanted to figure out why some students are more likely to believe these neuromyths. They looked at things like how well students can reason scientifically, how they think about knowledge, and what they believe about science itself. So, what did they find? Well, the students in this study, who were psychology students in Honduras, didn't do great on scientific reasoning. On average, they only got about half the scientific reasoning questions right, and even worse, they believed a lot of neuromyths. They believed almost 8 out of 12 of these fake brain facts. That is a lot of misinformation. They started by looking at basic things like age, gender, and academic scores. These things did play a small role, but not a huge one. Students with higher grades were a little more likely to have accurate beliefs, but it wasn't the whole story. The real interesting stuff came when they looked at how students thought about science and knowledge. This is the key finding. The better a student was at scientific reasoning, the more likely they were to have accurate knowledge about the brain and avoid neuromyths. Think of scientific reasoning like a built-in BS detector for science. It helps you look at evidence, come up with good explanations, and figure out what is real. But here is the kicker. If a student believed that science was heretical, meaning they thought science went against their cultural beliefs or personal values, they were more likely to believe neuromyths. So, if science felt like it was telling them something wrong based on their existing beliefs, they just accepted the fake news instead. When they added in how students viewed science, their critical thinking skills, and how they approached knowledge, the whole picture got much clearer. These mental tools were way more important than just getting good grades. Scronegative Perceptions of Science Scale (NPSS) is a 20-item Likert type instrument with 5 response options. 1 strongly disagree. 5 strongly agree that is designed to assess perceptions towards science. Keterampilan, they also looked at negative beliefs about science. Things like believing science is too complicated, or that scientists aren't honest, or that science contradicts their religious or personal beliefs. They found that students who thought science was limited, meaning it couldn't explain everything, or that it clashed with their values, were more likely to fall for neuromyths. Scrolltha Critical Thinking Disposition Scale (CTDs) SOCU 2013 comprises 2 dimensions, critical openness and reflective skepticism, which reflect the tendency to learn from past experiences and critically evaluate evidence. Keterampilan, it is interesting because critical thinking itself, having that open mind but also being a bit skeptical, didn't directly predict believing fewer neuromyths in the final analysis. But the study suggests that scientific reasoning, which uses critical thinking skills, is the real driver. It is not enough to just want to think critically, you need the actual skills to evaluate information scientifically. Scroll in the full model, scientific reasoning emerged as the strongest and most significant predictor. Higher scientific reasoning was independently associated with greater accuracy in neuroscience knowledge and lower endorsement of neuromyths. Herinti Keterampilan, so the absolute biggest predictor of not believing neuromyths was having strong scientific reasoning skills. It was more important than anything else they measured, including academic performance. This suggests that simply getting good grades isn't enough. Universities need to focus on teaching how to think scientifically. Scroll notable academic score, which was a significant predictor in the base model, became non-significant in the full model. Fui Keterampilan, this is a really important point. That academic score, which looked good at first, kind of disappeared when they looked at the deeper thinking skills. It means that good grades might be a sign of good thinking, but it is the underlying thinking skills themselves that truly protect against misinformation. Scroll's study has several limitations. Although factor analyses produced excellent global fit indices for the knowledge, based measures, their internal reliability was low, indicating limited item cohesion. Keterampilan now. No study is perfect. The researchers were upfront about some limitations. For example, some of the tests they used to measure understanding had low internal reliability. That just means the questions in those tests didn't all measure the same specific thing very consistently. So we should interpret those results with a little caution. Also, the sample was limited to university students in Honduras, so we can't automatically say this applies to everyone everywhere. Scroll in conclusion. This study shows that scientific reasoning and epistemological beliefs predict neuroscientific knowledge and neuromyth endorsement among psychology students beyond academic performance. So what does this all mean for us? Well, it highlights that believing in neuromyths isn't just about being uninformed. It is deeply connected to how we think about knowledge, how we approach science, and our ability to reason scientifically. For students, especially those in fields like psychology, developing strong scientific reasoning skills is crucial. It is not just an academic exercise, it is about building resilience against misinformation and making better evidence-based decisions in their future careers. Therefore, educational policies and curricula should explicitly strengthen scientific thinking and epistemic frameworks through evidence-based refutation of myths, training in scientific reasoning, and instruction that differentiates science from pseudoscience, thereby promoting critical judgment and responsible psychological practice. The researchers suggest a few things. First, universities need to actively teach scientific reasoning. Maybe through problem-based learning, they need to explicitly tackle neuromyths, show students why they're wrong, and teach them how to spot the difference between real science and pseudoscience. If science feels like it is attacking your existing beliefs, you are more vulnerable. So education needs to build bridges, not walls, between scientific understanding and personal values. This research is a great reminder that science literacy is more than just memorizing facts. It is about developing the skills to critically evaluate the world around us, especially when it comes to something as complex and fascinating as the human brain. What do you think about these findings? Have you ever encountered a neuromyth that sounded totally believable? Let me know in the comments below. Don't forget to like this video and subscribe to RUBIN'S Mind Lab for more deep dives into the amazing world of psychology. See you next time.